Hello folks, so following on from our success getting a Blinky to work, next thing I'm going to do is to get printf to work, see if we can get something out to stud.io. So to do this we're going to need to use set up a UART, and one of the handy things of this particular device that we have here, if I show you, is that through this debug header we also have a connection to one of the many UARTs. There's 6 UARTs on this chip, and it's connected in such a way that we can have this come through our USB connection rather than us having to have a separate UART connection. So the next thing to do is to figure out whether we have this port connected, and this is reasonably easy to do if you go into your start menu and we go to device manager, and if you look at part, you'll see here there's a PIC32MZ on board virtual COM port and it's COM5, so that's a really easy way to figure out which COM port it is. Next thing to do is to set up your favorite terminal emulator. So I use TerraTerm on COM5, and make sure as well that you have the right, so we've got a baud rate of 9600. I'm going to up that to 115.2. Okay, and we'll leave that just running there. Might just set the font to be something a little bit more visible. So, there we go. So what we want to do now is to figure out how to get this device to actually send a something out to the UART. So you may remember that when we had this earlier on, oops, we've got our timer 2 set up here in the project graph. We now need to set up the UART and the stud.io. So how do we do that? Well, you'll see under the device resources there's something called stud.io. So we can add that on here, and it's expecting a UART. So what we can do there is under the peripherals here, we can add a UART. And we're going to do UART 6, which I happen to know is the one that's connected. How do I know that? Well, we have to look through the documentation for the development board. It's a little bit hidden away, but if you know what you're looking for, you can find it. So you'll see here, you've got the main processor itself that we're programming. You'll see it's UART6TX, and that goes into the debugger. So we know it's UART6 that we're targeting here. So let's add UART6. There we go. And then we need to connect these together, which you do by just putting a little line like that. So let's look at UART6. So here we go. We're just going to use normal blocking mode, nothing clever here, and you'll see that the clock frequency is 4000. Now remember these just to go back here to this PB clock. I think this is PB clock 4. No, it's not. It's PB clock 2. PB clock 2 is the UART clock, and you'll see by default it's divided by 2. And you'll also notice that the error is 3.5%, which I think is I think 5% is the sort of most out of spec you're supposed to be allowed to do. I'll just add on to that, if you increase the clock frequency speed, you can get a better. So if I made this so it's divided by 1, you'll see the baud error decreases. But we'll leave it as divide by 2 just for now as the default, because it's good enough for what we're going to do here. The next thing we need to do is we need to set the pin so that you remember if we looked at this here, this is going to hit the pin on here. So we need to set the pin on this microcontroller to have UART 6 on it. By default, UART 6 isn't actually tied to a particular pin. We've got a peripheral pin select that we need to set as well. So to do that, if we go back into here, before we do that, we need to know exactly which pin physically is connected on the board, because we don't know that yet. Now we can do a little search to see if we can see in the schematics where this is. Okay, oh, that's not telling us. Have another look. UART60X, here we go. So UART60X is on RF2. So now if we go onto here, we go to RF2 in our pins, and we scroll down, there we go, U60X. That's it. So if we look at the pin diagram on here, so you'll see LED 1, which is what we set in the previous example. You see U60X is set just here. So now we've done that, we need to do a generate. There we go. And then in our main, we want to print something out. So we'll do this right at the beginning here. We'll do printf. There we go. And this is all very well, but printf, we won't have a function prototype, so we need to do hash include stud .h. And let's do a build, make sure that we haven't missed anything. Very nice. Okay, so I'm going to make it a little bit smaller. Let's get this here. Yeah, you notice that where I've set this up, it's insistent it's not in the main loop. So let's just program that up. There we go. Hello world. And you'll also notice that it's still blinking. So this is the same device, and that's how you get your printf to work. Thanks for watching.